All right, time for another Fireside Chat with the Xperts. It's me, David Kruidhof, here again with Mr. Griffin Lemaster, our VP of Manufacturing. And today, brought Griffin here because we want to talk about our TruView PC2 and the evolution of the system. We recently granted a patent on the technology that we use here. So just want to have a discussion about that, dive in and get the whole story from you, Griffin.
Of course.
Welcome.
Happy to share the experiences.
Yeah, so our parts counter has been a unique system on the market. Parts counting using X-rays has been around for a little while, but the cabinet itself is unique, and gotten a lot of great compliments from our customers. But since you're one who designed the machine, at least played an integral role in it, if not the entire role, wanted to touch base with you, get the history on that parts counter. How long ago did that start, and how did you guys go about doing that?
Sure. Well, we first started seeing that parts counting using X-ray technology come out. What was that? Probably 2015, maybe around there. And we, looked at it, explored the market potential. We liked it. We liked what we saw. So one day, probably 2 weeks before a trade show, we said, "Hey, let's get a parts counter at a trade show, the next trade show coming up." And we definitely did. We made it happen. And I will tell you that parts counter we had at that trade show was a piece of shit. Without a doubt. It was an awful machine that we put together in 2 weeks just to showcase we had the technology. And but I mean, the amount we learned from having that machine there was crazy. What we did, we took our current prime, got rid of the bottom, set it on top of a cart, and basically put a big sensor on the bottom, source on top. And we put some elevator in there that raised it up and down. It was a garage door motor that lifted this that lifted this stage up and down real quick. But that was our first attempt at a parts counter, and it was ugly and it was really bad. But it said, "Hey, let's push the idea," and that's what it did. It pushed the idea. So after that trade show, what we did was we literally as soon as we got back from that trade show that week, right, we cleaned up, packed up, came home, and that next day, probably 5 or 6 of us sat around just at the break room table, and we said, "Hey, how can we make this sellable, right? What do we need to do to make this unique, make it sexy, make it impressive, and make it work, right?" And so the whole team we had, the CEO, myself, I think Glenn was there, our VP of sales at the time, Brian was there, Carlos. I mean, we had all the minds there trying to put stuff together and how can we make this sellable. And it was a one of the most productive conversations I remember us having as a company is, hey, what do we need to make this work, and when are we going to do it, right? When can we do it? And we were spitballing ideas, throwing ideas out left and right. And some of the most unique ideas that we thought we could sell to our customers and would be useful were the mobility of our system. So you put it on casters, right? You can roll it from inventory room to inventory room. We like that. But then we said, hey, at that point, we said, why does it just have to be mobile? We can also, if it's mobile, shouldn't you be able to move it anywhere at any time and use it, not just move it somewhere, plug it in? So we decided, hey, let's put a battery pack in there, and we ran it off battery. And so it was like, no one else is doing that, and we thought this is really good idea. And so we that was our key insights for that. We wanted to make it smaller too, right? The other ones on the market, they were 10 feet high, had to be bolted to the ground. And we know why they were 10 feet high, and I'll get to that point here in a second. But they were so heavy and so fixed, and we thought we could really improve the customer's experience by making it, mobile and giving them some variability that they could use.
Yeah, I remember watching the intro video with that machine. I wasn't at Creative Electron then, but I think you Bill's in the front talking about it, and you wheel it in from the back behind him.
Yeah, we staged that pretty well. that was
but it was really impressive.
The first of the new design.
outside of the company at the time, just seeing like, wow, like a mobile X-ray system, right? And for your parts counting in your inventory, you know, I've been in a lot of stock rooms in the electronic manufacturing world, and you know, most of them don't center around one specific spot. There's rows over and over again, right? Around corners you got to go to, and if you want to just count things right off the shelf, you can do that with that machine. So it's a pretty neat idea. I was definitely impressed.
That was the concept. You're right, and that was definitely Bill's marketing promos. Hey, let's start the video, and you just walk it up to me. It's already going to be on, right? And so, yeah, 3 seconds of fame for myself.
Well, here's your next 12 seconds for your 15.
Yep. That was that initial design, right? And solid cabinet. We actually had it manufactured by a guy who made kiosks, and they made this steel solid cabinet for us. You know, we designed the whole interior to work with the battery, as I said, and it was just a push drawer. And that drawer you push open and close yourself. I mean, it's basically a easy way just to load a reel or multiple reels at the same time. And so with that, I mean, once we actually had the counter in place, the physical cabinet that we could use, then started actually the heavy work is what I call it, is the software, the processing, the algorithms that were used to, you know, count the components on the reels. Because initially the idea when we made that awful first parts counter was, you know, Bill went over a weekend and created a MATLAB script that could count the parts. And, you know, it did okay for a little bit. But then once we actually started counting lots and lots of different parts, different shapes, wanted to get into 4 reels at the same time, all these other, you know, challenges presented themselves. And so we started developing our AI before that. We thought this was a great application for it. Let's put an AI algorithm into use. Let's develop, you know, using machine learning technology. Let's see what we can do with this application. So we started pulling out, you know, we got thousands of reels from various sources, all obsolete, used, whatever, from customers, collaborators, and whatnot. And we got a ton of reels in house, and we started taking pictures of everything, right? And started training this algorithm to count components. And and you know, when the reel was right there in the center of the image, not a problem. It actually went pretty well. And I mean, we count probably 95% of components that we saw when we put the reel in that center there. The issues we started seeing, and even the algorithm we couldn't get to work well, was when we basically started doing that quad counting, right? You put 4 reels on the stage, flat on the stage, and take images. And the biggest issue that presented itself was parallax. And, you know, we know what parallax is. It's, you know, it's something that's going to exist either way. And basically what it was is when you have those components on the outside of your reel overlapping with each other, as opposed to the ones on the inside. When you have a nice clean line, you can see around it and count it. When they start overlapping with each other, that causes problems with the counting. And so, you know, we racked our heads. How can we count this? And we thought we could just train enough. We thought if we just trained enough images with the AI algorithm, it would a solution would present itself, right? Using AI, right? That's the magic box. It's the magic keyword. A solution will come out if you just train enough. And so that involved, you know, hundreds of hours of interns looking at images and counting the parts and saying, this is a part here. No, this is not a part there. When realistically, we were trying to solve the wrong problem, right? And we recognize this. How, you know, we can't get rid of parallax. It's always going to exist. There are certain ways to mitigate it, such as for example, competitors, they might use different technology as far as they might use a line scan camera as opposed to a flat panel. You're going to get less resolution, and you're still going to have parallax on the outside of the edges because you're still having that cone beam from your X-ray source coming out. And so you might not have parallax in the direction that it's moving, but on those outside edges, you'll still see it. So it's a little easier, but less resolution, slower technology. We'd like to, you know, we want to do all of our 4 reels in one shot. And so we were kind of moving along to, you know, what else can we do? And again, so now we had another we've already sold a couple of these parts counters at that point, and we're realizing it's not performing as well as we want to. So we had to have another one of those design meetings where we all sat down and racked our brains. Again, how can we figure this out? Is this the end of the product? Are we just not going to invest any more time in this, or do we keep pushing? What else can we do? And really, what it came down to is what we discovered, you dig down to the root cause of the problem. And we found the root cause wasn't the parallax itself. It was the fact that the parallax was uneven. So when you have 4 reels setting around flatly on the stage, you'll have basically more parallax on the outside corners of the 4 reels than you will have the inside corners of the individual reels. And so, because each of these reels is an individual different component, it takes, each of those quadrants is treated as one image. And so you don't have a even parallax around the reel. And so, hey, what do we, if we don't have an even parallax around the reel, we just have to, let's move the reels so that we can get, so they're in line with the source. So basically the direction of the source, the beam of the source where it hits the center of the reel is normal to it. I think, David, do you have that patent available that you could show? I might actually clean this up and make it easier to understand rather than have me just explain everything.
Yeah, let me pull it up here. So this is our patent on USPTO.
Mm-hmm.
So this image is the explanation of parallax. So as you
what
can
it
see
is,
here,
So an image on the outside will cause the shadow of the image to appear to grow, right, as opposed to the center image.
So the center one, you get a nice perfect square. This one, you get more of a rectangle.
Yeah, and you get those. If you get multiple images there, or multiple parts there towards the outside, they start overlapping, right?
Right.
The center, they might be separate, they might stay separate, but once you get into the outsides, those edges are going to start overlapping with each other, which is parallax. We know about it. It's a known problem. It's physics. Not much we can do. But how we
broken the laws of physics yet?
We've been trying real hard. Still kicks our butt here and there.
So here's the original design, right?
Yeah. Yep. So this is the original design when you have the 4 reels flat on the stage. Essentially what you get is you get those parallax to be greater on the outside edge of the reel than on the inside of the reel.
Yeah.
Yep. And so that was really what the root cause of the problem was that it was tough. It was becoming extremely difficult to analyze one picture when it was essentially the parallax was skewed and it wasn't even. And so what we did is we ended up tilting the reels so that the reel itself is normal to the direction of the X-ray photons at the center.
Here, right in the middle of the reel.
Exactly. So you keep that normal, to keep that direction normal to it, and that basically evens out the parallax on the 4 reels. And so once we have that parallax evened around the center, then we have essentially 4 pictures that are centered, that it can be treated as if the part was in the middle, part is on the either quadrant. Either way, now we can actually do an easy measurement. And once we made that change, boom. I mean, the algorithm started working beautifully and wonderful. Yeah. And that was, it's honestly, it's simple, right? It's really simple. Just tilt it so it's normal to the cone. And once we have that, then the algorithm can read that even distribution of the parallax around the reel and pick up the parts and identify the parts much easier. And so once we had that in place and gave that a couple tests, we said, yeah, this is definitely the product we can keep selling. And so we pushed that, and that was the big breakthrough in that parts counter design for us. Now, of course, us being us, we were never happy, right? We're going to keep pushing to make it better and listen to customer feedbacks. We learned some things. And again, we, hit the design ground again. And then we basically redesigned the cabinet for a third time. And now, that's what the PC2 is now. So we have a beautiful, sexy cabinet where, the form factor is much prettier. It still has the same, basic layout where the source and detector are. How we stack the reels, still exactly the same, but it looks better. And so why, but so the reason, I guess, I said earlier that, why are these other systems 10 feet tall, right? And why are they bolted to the ground? Well, they are 10 feet tall to, that's their answer to fixing the parallax. The farther you get that source and sensor away from each other, the less parallax you're going to have. And so we wanted to still do that, but keep it mobile and keep it maintained. So we have a decent distance in there, but it's not as far as those 10 feet tall systems. And they put that source way up top, and it gets really heavy. It's top heavy, and that's why it gets bolted to the ground. And I mean,
the added distance also adds, you need more power, right, in your source.
Correct. Yeah, you'll need a higher power source, or
the distance between the detector
or something.
Yeah, you need that higher power to reach and still penetrate the samples enough to give you a good image. So, problem with that then is cost, right? Let's repair.
It's all going to add to your cost. Yep. And so those are big, heavy systems. They cost that much. And I mean, I'm not going to knock competitors as far as their performance. I think a lot of them have pretty good performance. A lot of them count pretty well. But I don't think that was really, everyone's claiming 99%, counting reliability, right? I'm not going to go say others aren't, but we definitely are at that 99%. It's always going to count very accurately to within 99% of your components, and it works great. But I think our benefit is really just the uniqueness of the design, the mobility of it, the size, and it's not going to take up a full room.
Yeah. That's one of the advantages of the machine is that size, right? It's about 2 feet by 2 feet footprint, and it rolls around. So you move it out of the way for a little bit. You can do that really easily.
Yeah. Like going back to the AI for a second, that's still actively being improved, right? We still have customers here and there saying, "Hey, this reel doesn't really work too well," so they'll come back to us and say, "Okay, we'll train it on there," and they're good to go. And so that's still active and still working really well. As far as I haven't heard any negatives in that regard, and I think everything's moving pretty smoothly there.
Yeah, and that's also the advantage we have with that full software team we have in house, right above you.
Yes,
there in the office. Having a team that's actively developing this. I think they just released a new version with improved interface for the tubes and trays as well, right? So we're always getting feedback from our customers and developing new features to it. One of the other things that we have on there is a TruView inspector, right? So the idea here is you have an X-ray cabinet, you could put whatever you want in there, really.
Doesn't have to just be parts counter, right?
Yeah, it doesn't have to just count parts. We have some customers who put a full PCB, assembled PCB in there, and you can get a nice overview picture. You're not going to get, you're not going to be able to zoom in on a VGA and get real nice image of that. That's what our other machines are for. But you can check if things are there, right?
Yeah.
Everything gets placed down. Is anything askew?
We've seen it used quite a bit actually in the medical devices, right? And checking putting those devices in there and checking for, parts and placement, making sure everything's there, it's in the right position, orientation, and it's super easy for them to just open a drawer, load it, take a picture.
Yeah. So very easy to use. The other feedback we've gotten a lot over the years, as there's a wide variance in stockroom situations. Some have a really nice, they've invested a lot to make a really nice storage situation. Some people have a little bit more of a mess.
Boxes on shelves.
Right?
Lots of boxes all over the place.
So some people want a live, accurate count, to the minute. And that's where this really excels in that. As soon as your reels come off the pick and place machine, you can count them and put them back into stock. You know exactly how many you have. But to do that, you actually need, other systems in place, a good good ERP, some sort of tracking of where it would be, whether it's a storage tower or just a smart shelving system. But that whole package, is an investment, right? And for the customers who aren't there yet, they've asked to, hey, can we borrow the machine? Right.
Mm-hmm.
I just need to do an annual inventory. I need to do a quarterly inventory, whatever it is. And these are so easy to use that we just, we ship it out to the customer. We can plug it in and start counting pretty much out of the box.
Yeah, and that wasn't part of the design intention, right? We didn't intend this to be a rental machine that we could just send out, but it actually works very well in that regard, size and mobility, right? We even designed the crates for it, right, where they can just roll out of the crate onto the ground. They don't need a forklift. So we just rolled out of the crate and go.
It was a ramp, right?
Mm-hmm. Yep. So it was a happy, learning curve there.
Yeah. So we've had a number of customers who rent it, roll it out of the crate, do their counting for the week, or maybe just a couple of days. What used to be a week, we've done a couple of days. Roll it back in the crate, seal it all up, and ship it back. So it's, like you said, it wasn't really the intention of making it a mobile system like that, but a really good, useful side effect, so to speak, of the design process.
I mean, you're right. It works better as it's works great if you have your ERP system integrated with it. It can update that immediately. Right. Let you hit that as close to real time inventory as you can, and without having to suffer big loss of downtime, right? Because you ran out of a component that you didn't realize you were that low on. Yeah,
exactly. And we've had large facilities purchase 2 machines. And the ROI for them was like 3 months. It paid for itself so fast for them. But again, going back to the smaller facilities that may not have all the systems in place, it doesn't make sense to buy one, right? Why drop that much money on a machine that it's going to save you an hour or 2 a year, because you don't do your counts too often. That's where it just doesn't quite make sense to purchase something. So we're happy to have had customers approach us about a rental situation. So we've been able to build up that program pretty well. So always a development, right?
All systems are always in development. That's part of what we do. That's part of who we are, right? We're always looking to every system we build. We're constantly having more ideas for it that are going to get implemented on the next go around, right? And every time we build it, or every time a customer comes back with feedback, if it's something we can change there, we will, right? And if it's something has to wait for a new design rev, okay, we'll wait for a new design rev. But that's constant evolution of our system. It doesn't stay as it is for more than a year, to be honest. Without some nice improvements.
For sure. And the software too, right?
Absolutely. I mean, more so on the software than the hardware side. Yeah.
It's easier to push out software updates to customers than go there and put in a new hardware. It's always exciting to be here at Creative Electron with all the innovation and the changes that are happening, and be pulled into those design meetings of, hey, we got a problem, let's just brainstorm, right? Who's here? Let's all go gather in the room. 5 of us.
Well, now we have to do it in this form. We have to do it on Zoom, but
we'll be back soon.
Yeah. And that's one of my biggest challenges of since this pandemic is not having those quick, everyone's next to a machine. We just happen to be there and just have spontaneous conversations about how to improve it. Those aren't happening as frequently. And so we have to schedule those in now. And so, they're more productive when you schedule them, but still you might miss them. You might have missed some things.
Yeah, I mean, we've had countless conversations just in front of a machine of, hey, the customer said this, And it wasn't a big point. I wouldn't have made called a meeting to bring it up. But if you're standing there, it's easy to, pass on a tidbit of information. And next time you're designing something, it's like, oh yeah, the customer requested this. I wonder if I could tinker and add it. Right? Definitely looking forward to being back in the office more frequently.
Yeah, I think things are starting to open up. More people are starting to come back in. So it's nice. It's nice having those bodies around.
Yeah. All right. Well, thank you, Griffin. I appreciate your time. This has been great. Very insightful. So, as usual, everyone, if you have any questions, feel free to leave them down below if you're watching on YouTube. or go ahead and email us at info@creativeelectron.com. Thanks.
Thanks, guys.